Hey everyone, so let us talk about this Leetcode problem, missing number. So you are given an array nums containing n distinct numbers in the range 0 to n, and you need to return the only number in the range that is missing from the array. Okay, so if we consider this example, we have an array. The size of this array is 3, so n is equal to 3. So ideally, it should have all the elements from 0 till 3, including 3. But over here, we see that 2 is missing, so return 2. Similarly, over here, the size of the array is 2, so the numbers ideally should be included are 0, 1 and 2. But over here we see that 2 is missing, so we return 2 over here. So there are many ways of solving this solution and we will discuss couple of them over here. First approach would be, to first sort the array. So let's say we have this array 3, 0 and 1. So what we can do is we can sort this array. So we get 0, 1 and 3, and then call a for loop on this sorted array and check each element with its index over here. So obviously we see that when the index is 2, the element is not equal to 2. That is why number 2 is missing. So we can return 2. Another approach would be to know that we know that the numbers are from the range 0 to n, okay, and we also know that the formula for first n natural numbers is n into n plus 1 divided by 2 over here. Okay, and we can get n how? We can say that nums dot length will give you n. Now that we have got the sum of first n natural numbers, when we run the for loop on the array, what we can do is we can say sum minus equal to each element. This will give us, after the entire for loop, this will give us some sum which will be equal to the missing number over here, and we can check that. So let us write this solution because uh, this was quite an interesting way of solving it instead of using the brute force approach. Okay, so let us say we can say let n equal to nums dot length and let sum equal to, we can say, n into n plus 1. We'll have to use the brackets over here, n plus 1 divided by 2. Okay, so we have got the sum. Now what we can do is we can call a for loop. So for let I equal to 0, I less than nums dot, we can say I less than n, I plus plus. Okay, and then we can say sum minus equal to nums of I. Now whatever has remained, we return. Okay, so let us check this solution. Alright, so we've got all our test cases accepted. We'll submit this. Okay, so we've got an acceptance. Okay, let us discuss one more solution over here, and that would be using the binary search. Okay, so let me go to the whiteboard and talk about it. Okay, so let's say you have this uh, array 0, 1, 5, 4, 3. Okay, we have this array. Now for binary search to work, we'll have to first sort it. We'll have to sort it. Okay. And when we had discussed the brute force approach, what we had said that we'll, traverse the entire array and check with the indices. We'll have to do the same in the binary search, but in the advantage over here of using binary search is that we always divide our array into halves. Okay, so now that we have sorted our array, so it will look something like this: 0, 1, 3, 4, and 5. Okay, and what we'll be doing, we'll be doing the same thing, but we are doing the binary search on it. We'll be comparing the elements with the index over here. Okay, so let us write the solution and see how it looks using binary search. Okay. Mm. So first I need to go and sort the array. A minus B. Okay. So this sorting function on in JavaScript will mutate the original array. So we'll get this array sorted. Okay. So let me have a start index which is going to be equal to 0. Let end is equal to nums dot length minus 1. Okay. Now we need to do is we need to say while start is less than equal to end. Okay, so when both the indexes do this loop till both the indices meet. Okay, and when we say if nums, okay, and then we'll also have to calculate the mid over here every time. So let mid equal to, we use the general formula that is available, start plus end minus start divided by 2 over here. And since this is JavaScript, we'll have to convert, because we'll get the, sometimes if the, let's say the size is 7, so we'll get the mid as 3.5, which we don't want it in decimals, we want it in integer. So we'll say math dot floor on this output. Okay, so now we've got the mid. Now we need to check if nums of mid is less than mid. Okay, if nums of mid is greater than mid, that means what? Over here, so if this is the mid, for example, then if this mid is greater than the index, if it is greater than index, then obviously we need to shift our end. Initially our end was over here, we need to shift it to this index. Okay, so what we'll say is, we'll say end is equal to mid minus 1, else we say start is equal to mid plus 1. Okay, and we are calling this function until start is less than or equal to end. All right, so now when this entire loop gets executed, the answer would be in start. So let us check this solution. All right, so the test cases have been accepted. Let's submit it. Okay, so we've got an acceptance. All right, so this was an interesting problem because there was many ways of solving it. One was like brute force. Another use is using the formula n into n plus 1 divided by 2. Then we also used binary search over here. There is one more solution that is using XOR, but we will be discussing it in some other videos maybe. All right. Thank you.